Hey, what's up, guys? We're back with day 94. I just want to solve one differential equations problem here. We saw one today with where we used letters different than y and x. So I just want to show you one more of those and solve it and just kind of show you the level of difficulty that it can get on here. Okay, so here is our differential equation. Our differential equation is dH dt. So let's say it's it's the temperature of something cooling, right? So dH dt equals negative parenthesis h minus 13 to the 2/3 power. We want to solve for y equals h of t with the initial condition h of 0 equals 4. Okay, so if we wanted to solve this type of problem, to find h of t, right, we want to get it down to go from dH dt to h of t, we have to do an antiderivative, okay? And we have to do this by separating the variables. Once again, notice that there's no t on the right side of the equation. That's okay. I'm just going to leave that coefficient of -1. I'm going to leave that there to be with the dt, and I'm going to divide the right side by the quantity h minus 13 to the 2/3. So separating the variables here, I end up with this. I end up with negative dt. If it helps you, think about that as a number, -1 dt. Right? We can always say that's the same as -1 times dt. Okay. So after we separate, then we integrate. Now again, because of that 2/3 power there, this is not a natural log problem. Okay? This is going to be a bump and divide problem. And we're just going to take that h minus 13, because it's going backwards, if we were doing the derivative, there's not going to be a chain rule component because this will just be times 1. We're just going to think of that h minus 13 in there to solve this antiderivative. Okay, so I'm going to integrate both. Because this is a bump and divide problem, I'm going to rewrite this as integral quantity h minus 13 to the -2/3 dH equals integral of -1 dt. Okay, so this is going to be a bump and divide. I don't have to worry about a u substitution here. I mean, I could do a u substitution and let u equal h minus 13, but the derivative of u would just be dh, and there would be not really much of a substitution here. So I'm just going to bump and divide, keeping that h minus 13 on the inside. So executing this antiderivative here, I'm going to bump the power up by 1. -2/3 plus 1 is the same as -2/3 plus 3/3, which gives me a power of 1/3. Then I got to divide by 1/3. Dividing by 1/3 is the same as multiplying by 3. There's my bump and divide. And again, just ask yourself, would that derivative give us h minus 13 to the -2/3? Well, 1/3 times 3 would make 1. H minus 13 to the -2/3 times the derivative of the inside, which is just 1. So yes, that works as our antiderivative. Okay? That's probably the hardest part of this whole thing. The antiderivative of -1 dt, right, when it's a constant, I just tack on a t here. So this is going to equal -t, and I put my plus c on the right side. Okay? Now I have to plug in my point. The point set h of 0 equals 40. This is my t, this is my h. Remember, t is acting like x. H is acting like y. So plugging this in to solve, I'm going to get 3 times 40 is going to go in for h. And 0 is going in for t. So 40 minus 13 is 27. So I get 3 times 27 to the 1/3 equals, negative 0 is just 0, so that equals C. To do 27 to the 1/3, right, I know the cubed root of 27 is 9. So I get 9 times 3, and I get 27 as C. Okay. So that's how I solve for C. Now I'm going to plug that back into this equation right here. And I'm going to get 3h minus 13 to the 1/3 equals negative t plus 27. Now I just have to solve it to say h equals. So the first thing I'm going to do is go ahead and divide everything by 3. So h minus 13, I'm going to think of this as a cubed root now, equals negative 1/3 t plus 9. I'm going to divide both of those by 3. Now to undo a cubed root, I'm going to raise everything to the 3rd power. So I'm going to get h minus 13 equals the quantity negative 1/3 t plus 9 cubed. And then I'll get h equals quantity negative 1/3 t plus 9 cubed plus 13. So we'll take a look at a lot of these on Wednesday to get ready to test on this Thursday going into spring break. So that is it for today. I'll see you guys in class on Wednesday. Talk to you later. 2 chains. Bye.